Hello cadets, this is Nikita, your educator from SSB Safalta Academy, and you are at the right place if you want to join the uniform services. So in today's video, we will be covering the chapter Sound. Alright, so let's have a look at the topics we are going to cover in this particular video. So we will be covering sound, its production and propagation, the medium through which sound travels, waves and its types, characteristics of sound, audible frequency, reflection of sound and its laws, application of reflection of sound, echo. We will also see some numericals related to echo, reverberation, infrasonic and ultrasonic waves, application of ultrasound, sonar, and also we will see how the sonar technology works. We will see the human ear, its structure and its working. The content of this video is going to be very precise and in a concise manner. I suggest you to grab a pen and a paper and make notes of it. This lecture is going to be useful to all the upcoming exams you will be facing this year or in the upcoming years. So let's get started. Alright. So there are some basic points that we need to know about sound. First of all, we must know that what is sound. So sound is a form of energy which produces a hearing sensation to our ears. Alright. So it is a form of energy and there is a rule that energy can neither be created nor be destroyed. Right. So the same applies to sound as well. So now when we wonder about the production of sound, we know that we cannot create any energy. So we just transmit energy from one form to another, right? So what produces sound energy? Any kind of vibrations of an object, a particle, they create sound, right? Some of the examples we can consider are clapping, shouting, rubbing, scratching, tapping of our feet, birds flapping their wings, right? So all these things, what they do? They produce sound. So we can conclude that vibration of any objects can produce sound. And what are vibrations? Vibrations are to and fro movements of an object. Just consider pendulum. What it happens is it goes to and fro. Alright? While clapping also what we are doing? There is a to and fro movements of our hands. So this is called vibration. Alright? And this process, it produces sound. Consider the human voice. Human voice is produced by the vibration of our vocal cords, right? You can just try and keep your hand on your throat while speaking and you will notice that there are vibrations in our vocal cord while we speak. Then we must know about propagation of sound. What do we mean by propagation? Propagation means transmission of sound. Transmission or maybe traveling of sound from the point of generation to the ears of the listener. Alright? You need to understand that the sound is produced maybe somewhere at point A. So it needs to travel to a person maybe who is standing at point B, right? So how will the sound travel to this person? That is called the propagation of sound. At some point of time, all of you must have played Kho-Kho in their lives at least once. So the sound travels in a similar manner as we see the players of Kho-Kho. Suppose there is a sound that is produced at point A. So what happens is, suppose this is the sound. Alright. Now what happens is, this particle will push the another particle and set it into motion. And in turn, this another particle will set some other particle into motion and they will go on in a chain-like structure. Alright. Till it reaches the listener. Now you need to understand that these particles are not the sound. Sound is these lines, alright, which disturb the particles, which set the particles into motion. This root is called wave, alright. And what is this wave? This is sound wave. So now that we have concluded that sound travels through waves, alright. So here comes our next topic. We must know that what are waves, what are the various type of waves, and what type of wave is a sound wave. Alright. So waves are broadly classified into two major categories, that is mechanical waves and non-mechanical waves, which are also called electromagnetic waves. Now, the mechanical waves are the waves which require medium to travel. They cannot travel through vacuum. Whereas on the other hand, the electromagnetic waves, or what we call it non-mechanical waves, they do not require a medium to travel. They can travel through vacuum. Some of the examples of electromagnetic waves are light, microwaves, infrared waves, X-rays, ultraviolet rays, and radio waves. Now coming back to the mechanical waves, they are further classified into two major categories, that are longitudinal waves and transverse waves. Now the difference between these two types of waves is that the longitudinal waves move parallel to the direction of propagation of sound. Alright, suppose this is point A and this is point B, and the sound is traveling from point A to B. So the longitudinal waves will travel in a motion towards A to B or B to A. This will be the direction of propagation of longitudinal waves. Now in case of transverse waves, they travel perpendicular to the direction of propagation of sound. That is, if the sound is traveling from point A to B, the waves will be traveling perpendicular, up and down. Whereas in longitudinal waves, the waves will travel to and fro, that is forward and backward. Now sound waves are longitudinal waves, that is they move in the to and fro motion, front and back, front and back. And water waves are the example of transverse waves. We must also consider that mechanical waves require a medium to travel. So what are the mediums through which longitudinal and transverse waves, that are the mechanical waves, can travel? These can travel through solid, liquid and gases. These can travel through these three forms and they cannot travel through vacuum. This point must be remembered. As we all know that sound waves are longitudinal waves, right? That is, they move in a to and fro motion, forward and backward, this way. As we can see in the diagram, suppose this is a fog and this is vibrating. So when it's vibrating, it sets closest particle into motion. You can consider this similar to a spring. So when we push it from a direction, what happens is the spirals of the spring, they get compressed. They come very close to each other. So this is called compression. And in the form of waves, the upper portion of the curve is called crest. And the lower half is called throw. And in this particular representation, we can understand it by the compression and rarefaction. What happens is, if this particular object, this is an object, consider it a fog maybe. So when it starts vibrating, it pushes the particular object that is very close to it into motion. Alright? We know that this particular object, our fog, was vibrating. So it was also moving in the to and fro motion. So first it pushed the motion and then it itself went backward. So when it went backward, there was again some space. So the particles came to their original position. You can understand this by the concept of the spring. When we push it, we apply some pressure to the spring. What happens is the spirals of the spring, they get compressed. And when we move our hands away from the spring, what happens is it comes to its original position, right? So this similar process happens in the propagation of sound. Now let's have a look at the various components that affect the speed of sound. The first one being medium. Alright, the sound traveling at a particular speed is influenced by the medium through which it is traveling. Now that we know that longitudinal or the mechanical waves, they require a medium to travel. Alright, So sound will be traveling either by solid or liquid or gas. Now what happens is the speed of sound is maximum in solids, then comparatively less in liquids, and it is the least in gases. Alright, so the sound traveling in the solid will be the fastest, and the speed of the sound gets reduced in the gaseous form. Also, the sound is directly proportional to the elasticity of the object. For example, you can consider steel. Steel is the most elastic metal. It is a solid. Secondly, it is very elastic. So, the speed of sound is maximum in steel. Now, you can consider the example of vacuum. So, there is no elasticity in vacuum, and thereby there is no speed of sound in vacuum. Sound cannot travel in vacuum, right? Coming to the factor humidity. So the speed of sound is directly proportional to humidity. Why? Because we know what is humidity. Humidity is the presence of liquid, water vapors in air, right? And earlier we have seen that the speed of sound is higher in liquids as compared to gases. So what happens here? When there is high humidity, that is, there is presence of more water vapors, that is liquid in air. So the speed of sound gets increased. Next point is pressure. So there is no effect. Please remember this. There is no effect of pressure on the speed of sound. Temperature is also directly proportional to sound. The increase in temperature increases the sound. But the speed of sound at various temperatures need to be calculated through numericals, right? The speed of sound at 0 degrees Celsius is about 331 meter per second. And at 22 degrees Celsius, it is around 344 meter per second. So this is the tabular representation of speed of sound at 25 degrees Celsius in different substances or different medium. Alright. So for example, solids. In aluminium, the speed is maximum, that is 6420 meter per second. And the speed of sound is least in sulfur dioxide, that is 213 meter per second. Take a screenshot of this or maybe pause the video and please try to remember the speed of sound in various mediums and various metals. Alright. So the speed of sound in water is 1531 meter per second in seawater, right? Now let's look at the various components of sound. Alright. So consider, look at the third figure, right? If this is a sound wave, there are certain points that we need to know. First is the wavelength. Earlier, I have explained to you that the upper portion of the curve is called crest and the lower portion is called throw. Alright. So the mountain-like structure, we call it crest, and the valley-like structure, we call it throw. Now what happens is the distance between two consecutive crests or maybe two consecutive throws, that is called wavelength. Alright, and it is denoted by lambda. This is the sign of lambda. You can see here. And the SI unit of wavelength is meter. Second is the frequency. Frequency is how frequently the waves are being formed. Alright. Consider these two diagrams. So the upper one, in this you can see that the waves are repeating very frequently, right? So in this, the frequency is high, right? This is high frequency of sound, whereas in the second diagram, you can see that the repetition of the waves is less, right? So this is low frequency. Frequency is denoted by hertz, right? Hertz. And it is the repetition of vibration per second. It is represented by the sign nu. Alright, this is nu. We pronounce it nu. The next point that we all must know is the amplitude of sound. What is amplitude? Amplitude is the displacement of the particle from the mean position. For example, this line is the mean position. So how far the particle is moving. Again, you can consider the two diagrams that I have drawn. Consider the first diagram. Here you can see that the displacement from the mean position is very large, right? So here the amplitude is high. Whereas in the second diagram, the displacement is very less. So we can say that the amplitude is very less. Amplitude is denoted by A and the SI unit is meter. The next one is velocity. Alright, velocity or speed of sound. It is denoted as lambda into nu. That is wavelength into frequency. The points we must remember here are that the loudness or the softness of the sound is not determined by the frequency. Please understand this. Frequency denotes how frequently sound is being produced. Alright? Now quickly, let's have a look at the various terms associated with the chapter sound. First one being pitch. So what is pitch? Pitch represents the shrillness or the flatness of the sound, right? So the sound produced by females is high-pitched sound, whereas the sound produced by a lion's roar or by the males is low-pitched sound, is determined by the frequency. Frequency of sound determines the pitch. Now there are various qualities or timbre of the sound, right? First one is loudness. So what is loudness? Loudness is the amount of energy that is reaching the ears, right? So it is affected by the amplitude. Higher the amplitude, higher the loudness of the sound, right? The louder the sound, and vice versa. Next is tone. What is tone? Tone is a pure sound that is produced by a single frequency. There is a single frequency and that is called tone. What is note? Note is a mixture of different frequencies, right? Like various music instruments are being played at the same time. So what we make it? We call it note. And tone is a single frequency. Then there is noise. Noise is the sound that is very unpleasant to our ears. For example, the noise produced by the vehicles, right? The honking. And then there is music. Music is something that is pleasant to our ears. For example, the sound coming from a guitar or a violin, what happens is it is very soothing or pleasing to our ears. So that is music. The next point that we must know is the reflection of sound. So the sound also gets reflected similar to the light waves, right? The rays of light, we know that they get reflected when they hit a surface. Similarly, the waves of sound also get reflected. For example, this is a sound wave. When it hits a surface and it gets reflected back to the same medium, this is called reflection. Again, there are two rules that we must know, that the angle of incidence is equal to the angle of reflection, and the incident wave, the reflected wave, and the normal. All of these lie on the same plane. Alright? Now there comes a very important effect that is associated with the chapter sound, that is Doppler's effect. So in Doppler's effect, it is stated that if the sound is closer to the listener, alright, if the sound is closer to us, then the frequency of the sound will be higher. And if it is far away, alright, it is far away, then the frequency will be less. This is used to detect earthquakes and the cyclones and other weather conditions. For example, we can detect the direction in which a cyclone is moving, right? There, we fix some detectors at various points and we see where the frequency is increasing, in which direction. So for example, the frequency here is increasing at the center point, at this point in India. This is Andhra Pradesh, right? So we can conclude that the cyclone is moving towards Andhra Pradesh. Now, based on the frequency of sound, the sound can be classified into three categories. First one being infrared sound, second one being audible sound, and the third one as ultrasound. What is infrasound? Infrasound is any kind of sound that has a frequency below 20 hertz. We have studied that the frequency is measured in hertz, right? Hertz is the SI unit of frequency. So any sound below 20 hertz is called infrared sound. Sound between 20 to 20,000 hertz is called audible sound, which is audible to the human ears. And then any sound over 20,000 hertz is known as ultrasound. And what happens is the newborn babies, they can hear the sound up to 25 kilohertz. That is 25,000 hertz. And as the human beings grow older, what happens is the tendency to hear the higher frequency of sound decreases. Some of the animals that can hear the infrared sounds are elephants, whales, etc. Human beings lie in the category of the audible sound. They can hear from the range of 20 hertz to 20,000 hertz. And the example of ultrasound are bats, porpoises, and dolphins. In this slide, you can look at the various examples of infrared sound. So this is the reason that the animals tend to detect the infrared sounds which are not detected by the humans, and they know of the upcoming disasters. For example, volcanoes, earthquakes, avalanches. Avalanches is the landslide in snows. All these are detected by a few animals, and what they do, they react to it and they tend to run away. So we know that the speed of sound is approximately 331 meter per second. So in case of subsonic, the speed of the object is less than the speed of sound. Alright, it is less than 331 meter per second. Then there is supersonic, that is approximately equal to the speed of sound. And then comes hypersonic, which is very large as compared to the speed of sound. Alright. The jets moving at hypersonic speed, they tend to create a phenomena that is called hypersonic boom. What happens here is when the plane is moving very fast, right, at the speed of approximately 5 times than the speed of sound, right? So it creates a very low pressure at the point from which it has traveled. Now what happens is the air from the surrounding rushes towards the low pressure area and it creates this kind of structure and we call it hypersonic boom. So now let's have a look at the two very important phenomena of sound. First one being echo and the second one being reverberated sound. Echo is hearing back of our own sound, right? That is called echo. Why does this happen? This happens because of the phenomena of reflection of sound. So, for example, this is a person. There is a sound energy produced by him. And what happens is the sound waves hit some surface and travel back to his ears. So this will be echo. And then there is a fact that all of you must know that there must be a gap of 0.1 second between two consecutive frequencies for the human ears to detect it. Alright. So for example, there is a crowd of maybe 5 to 10 persons who are speaking consequently. So if there is not a gap of 0.1 second between the frequencies, between the sound produced by those people, our human ears will not be able to comprehend it, right? So we don't understand what all of them are speaking. There is a very unpleasant noise, right? For now, just consider that 0.1 second is the minimum gap that needs to be there for us to hear a sound back. Also to hear a echo. So the speed of sound at 22 degrees Celsius, that is approximately the mean weather we can say, So at that temperature, the speed of sound is 344 meter per second, right? We know that distance is equal to speed into time. So to calculate the minimum distance the sound must travel to be heard by the human ears, we can calculate it by the formula of the speed of sound at 22 degrees Celsius is 344 meter per second into the minimum gap required is 0.1 second, right? So when we multiply it, 34.4 meters, right? Now, what happens is, what is this distance? This is going of the sound, hitting the surface and coming back. So this is 2D. Calculate D, we will simply divide it by 2 and we will get 17.2 meters. That is the minimum distance that is required to hear an echo. Now the second phenomena is reverberation. In case of echo, there is a single wave that goes and comes back after reflection. In case of reverberation sound, what happens is there are multiple reflections of sound, alright? In case of reverberated sound, what happens is the echo lasts for a very long time, right? There is repeated reflection of sound. So the phenomena of reverberation can be found in big halls like cinema halls, etc. And to prevent this, because it can be very irritating to be hearing the sound repeatedly, right? Prevent this, we use certain sound absorbent materials like rough plasters, draperies, thermocol, fireboards, etc. Now, the phenomena of multiple reflection of sound, that is reverberation, is also very useful to the human beings. Alright. It is used in certain conditions, some of which are, first are the concert halls. Okay. We have to make the sound reach to all the people present in the large halls. So there is a large number of audience and we have to make the sound reach all of them. So what happens is curved walls are used. Alright. Either the walls of the hall are in a curved circular manner or there is a cardboard kind of thing that is placed is curved. The sound goes and hits that surface and reflects back straight, right? So in this manner, what happens is a large number of audience can hear the sound from a single source of sound. And the multiple reflection is used in megaphones, horns, musical instruments like trumpets and shehnais. Similar phenomena is used in the stethoscopes, which are used by the doctors to hear the sounds inside our body, mainly of the heart and the lungs. Previously, I told you that ultrasound is any sound that is larger than 20,000 hertz of frequency, right? So now let's look at the applications of ultrasound. We know that high frequency means higher number of vibrations, right? So what happens is it is used for cleaning very complicated or complex machines. For example, the airplane parts or the medical machinery, because they can't be reached by any other device. So what happens is a number of high frequency waves are targeted on that particular region. That these waves set the dust particle into motion and set free from the machinery. Alright. So this way the machinery gets cleaned. Secondly, the ultrasound waves, which are high frequency waves, are used to detect cracks between metals and other concrete buildings. These ultrasonic waves are targeted on the metal block or maybe the concrete block and it gets reflected by hitting a crack. Alright, if there is a crack, even a little bit of crack, the sound waves get reflected back towards the original position. Alright, and if the metal block is completely fine, then the waves will travel straight and they will be detected by the detectors. Now, why only ultrasonic waves are used? Because if the frequency of the waves is less, then what will happen? They will hit the object and they will divert, but they will travel straight, right? Just think about a slow ball hitting a wall, what happens is it will just move sideways. Whereas if we throw a ball at a very high speed towards a wall, what will happen? It will bounce back towards us, right? Similar thing happens here, and the metal cracks, even the smallest one, can be detected by this process. What is sonar? It is sound navigation and ranging. Alright, so in this process, there is this device which is fixed in the ships, and it is used to detect water, hills, valleys, icebergs, submarines, sunken ships, and the distance from the seabed. Alright, so how does this work? There is a transmitter and there is a detector. Both are fitted on the ship. The transmitter continuously transmits high frequency waves, right? Ultrasonic waves towards the ground. These waves hit the surface and are reflected back by the object, and then they are detected by a detector. For example, a wave is released by the transmitter. Now, suppose there is a pressure over here, right? So this wave will hit this pressure box and it will be reflected back to the detector. Now this detector will convert it into electronical signals which are later interpreted by the human beings. Now consider a numerical where the speed of sound, alright, the frequency of sound is 1531 meter per second. We have read this previously in the table, and this is the speed of sound in marine water, salty water, alright. And the time taken to detect the sound back is 3.42 meter per second. So now this will be calculated similar to the echo. 2D is equal to S into T, right? We will get 5236 meter, and this will be 2D. Why? Because the sound is produced from here, it goes and comes back, right? So it is 2D. D is equal to 5236 upon 2, that is 2618 meter. Alright. We know that bats fly in night, right? So what happens is they transmit ultrasonic waves. And the similar process happens here, that the waves produced hit the prey and are reflected back to the bat. This bat detects the echo and is able to find that how far the prey is from the bat, right? Again, this is the example of ultrasonic waves which are used by various animals to detect their prey. This is bat. What happens is it releases ultrasonic waves. They get reflected back after hitting the prey, and the bat is able to know that okay, यहाँ पे मेरा prey है and I will go and eat it. Similar happens in case of porpoise and dolphins. They produce ultrasonic waves which reflect back after hitting the prey. That is the small fishes or any other aquatic organisms that they feed upon. Next, this is ship or submarine, we can say. Similar technology is used. This is sonar technology, right? Ultrasonic waves are released. They reflect back after hitting a surface, and we are able to know about the underlying icebergs or sunken ships or detect submarines and other things. Coming to the last part of our video, let's have a look at the human ear and understand its various parts and how the sound travels to various parts of the human ear. Alright? So what happens is there is air pressure variation around our ear which is detected by the antenna. This pressure variation is carried forward to the eardrum. The eardrum starts vibrating and the sound is amplified by the three bones, hammer, anvil and stirrup. Now this amplified sound is carried to the inner ear. In the inner ear, there is a part, cochlea. What does this do? This converts the sound waves into electrical signals. And these electrical signals are further passed to our brain. Alright? Now, at old age, people tend to become sensitive to higher frequencies. They are not able to hear properly. So what happens is there is the use of hearing aid. In this, there is a mic and there is an amplifier. What happens is the sound is detected by the mic, it is amplified by the amplifier, and then it is transmitted inside the ear. And by this process, people impaired with hearing or sensitive to hearing frequencies are able to hear properly. Now here are a few questions for all of you. Pause the video and try to answer this, or you can take the screenshot as well. Earlier we have read that loudness of the sound is measured in decibel, right? dB. Now I want all of you to mention down below that what is the loudness that is audible to the human ears and government policies regarding the loudness of sound in the daytime as well as in the night time. So these are the questions. Now just have a look at question number 8. Flash and thunder are produced simultaneously, but thunder is heard a few seconds after the flash is seen. Why? So this is a very commonly repeated question in all the exams. What happens is the speed of light is more than the speed of sound. So this is the reason that we see the flash earlier and the sound is heard later on. Alright. Subscribe to SSB Safalta for more similar content. Thank you for watching.